Next, reactions. In the case of reactions having different stoichiometric coefficients. In the case of reactions having different stoichiometric coefficients. Different stoichiometric coefficients. But in the case how can we represent rate of reaction mathematically? So in the case of reaction involving different stoichiometric coefficients, for example, when hydrogen reacts with iodine gives hydrogen iodide H2, 2 hydrogen, 2 iodine. So we need to balance it. We need to put 2 as the coefficient, stoichiometric coefficient. This is called stoichiometric coefficient. So here 1, 2. Stoichiometric coefficients are for the hydrogen it is 1, for the iodine it is 1, and for the hydrogen iodide is 2. So in this case, this is the second case, reactions involving different stoichiometric coefficients. In this case, how can we represent rate of reaction mathematically, rate of this reaction mathematically? So ഇങ്ങനത്തെ കേസിൽ നമുക്ക് എങ്ങനെയാണ് rate of reaction represent ചെയ്യുന്നത്? So the difference in the stoichiometric coefficients, we need to avoid this difference. We need to remove this stoichiometric difference, or we need to avoid this stoichiometric difference. We should divided by each coefficient, each concentration, change of concentration of reactant, divided by its own coefficient, stoichiometric coefficient. Change of concentration y2 divided by, it should be divided by, what is that, divided by its own coefficient. So to avoid a difference in stoichiometric coefficients, we need to divide the rate of change of concentration of reactant with their coefficient. We need to divide. So that means rate of reaction equal to rate of reaction equal to what is this? It's right, minus sign delta changing concentration of hydrogen. This is by delta T. This is called rate. Rate means with respect to time. This term is called rate of hydrogen concentration. Rate of change of concentration of hydrogen. So divided by its own coefficient. What is the coefficient? 1. Divided it by 1, and that will be equal to minus delta change in concentration of I2. This is called rate, delta T. With respect to time, then it will be rate. Divided by its own coefficient. What is that coefficient? 1. So no need. Or equal to change in concentration. This will be positive sign because it being product side, delta. Change in concentration of hydrogen iodide. This is called change in concentration of hydrogen iodide divided by delta T. This is called rate of change of concentration. Rate of change of concentration of hydrogen iodide. This is called change of concentration of hydrogen iodide. This is called rate of change of concentration of hydrogen iodide. Divide with its own coefficient. What is that? With 2. Coefficient is 2. So better you can make 1 by 2. 1 by 2 into. So this is how we can represent the rate of reaction. The coefficients are different. Stoichiometric coefficients are different. This is the way for representing rate of reaction mathematically. For a general reaction, I can show you a general reaction. For a hypothetical reaction, AA plus BB gives CC plus DD. So rate of this reaction equal to rate of this reaction equal to, this is the reactant side. So what is that? We need to divide with the coefficient. A is the coefficient, 1 by A, divide. That means into minus delta A concentration of A divided by delta T. Or you can put minus here better, or you put minus here. Will be equal to minus 1 by B into change in concentration of B divided by delta T. That is equal to, because here the reactor coefficient A, B, C, D all are different. That will be equal to plus the product side also, it is product side. So 1 by C change in concentration of C divided by delta T. That will be equal to 1 by D change in concentration of D divided by delta T. So this is the general or mathematical representation of a rate of reaction for this hypothetical reaction. Hypothetical reaction പ്രകാരമാണ്. അതുകൊണ്ട് ഇവിടെ you can see that the coefficients are A, B, this C and D all are different. So we have two cases, a reaction involving same stoichiometric coefficient. So there is nothing, no need of dividing with the stoichiometric coefficients. Where we need to divide the stoichiometric coefficients means reaction involving different stoichiometric coefficients for the hypothetical. In that case or in that reaction, when finding out the rate of chemical reaction, we need to divide it with its own coefficient. So these are the two ways to represent it. No two ways. One way is especially for the reaction where the reaction has same stoichiometry. Other for the reactions involving different stoichiometric coefficient. So these are the mathematical representation of a rate of reaction. Mathematical representation of a rate of reaction.